All right.
Uh, Hi, Professor Heller. This is Group 2 doing our presentation for Homework 3. Homework 3 focuses on utilizing cross joints, inner joints, and outer joints for this project. With that in mind, we all did our 10 individual queries, and now we are pairing up with our group members and going over each other's queries. We chose 5 for the sake of time. We're gonna start now. Yusan and Shuli is gonna go first.
Okay, so I'm going to be showing Shuli's queries. Oh, give me 1 second. Wait, it's not letting me share this time.
You sure?
Yeah, I don't know why.
Try again. There you go.
You guys can see it?
Yep.
All right. So I chose the first one, which is receive all orders with customer details. The goal is to get every order with its customer details, which is order ID, order date, customer ID, and name. Why it's important is basically this is your master list of who bought what and when. So sales managers can use it to see trends over time, track repeat customers, or flag any missing customer info. This is the result. Okay, and then the second one is show each order line with product, quantity, and price. This is important because this is basically the bread and butter of the revenue and analysis. Finance can double check invoice details, operations can spot which products sell together, and purchasing can watch for low margin items. If a customer calls about an order mistake, this query quickly tells support exactly what was sold and how, like for how much it was. And this is the result for that. Then I selected number 4, which is list all customers and highlight those who placed orders exactly on the date of February 12th, 2015. This is important because this is great for targeted follow-ups or event-based campaigns. So, for example, for this date, we could see that if there was a special offer for Valentine's or something else surrounding February 12th. So you could do an exact search, which the results are shown here. Then number 7, which is list every possible combination of customers and active salespeople. This is important because this is like a matchmaking list. Management can use it to plan or to test what if pairings before assigning reps. It's also handy for internal dashboards when you need to see the performance of the active salespeople. And then lastly, I chose number 8, which is show all customers and all orders, even if some are missing matches. This is because sometimes you do have to have orders with missing customer records or customers who have never purchased. This query exposes those gaps. It helps data teams clean up the database and helps sales spot prospects who haven't bought yet. And this is the result for the last one. All right, I'm done.
Okay, hi everyone. Let me share my screen. Okay, hi everyone, this is Shirley. So I'll be explaining 5 queries that were created by my peer, which is Isan.
Shirley,
And
can you speak a bit louder to the microphone?
can you hear me better?
Yeah.
You can hear me, right? Okay, all right. So I chose Isan for 5 queries. So for our chapter 3 group assignment on multi-table queries in the worldwide database. So I selected these particular queries because they highlighted different join This is like left joint, right joint, inner joint, cross joint, and anti joints. And they each showed how SQL can solve the real business problem. So let's begin with the first queries, which is customer with no orders. So here she uses left join. So it's between sales customer and sales order. So that checks for your order ID is not null. So which means that it finds customer who have placed no order. So let me execute this. So here we can see that no orders is showing no because every or customer actually placed an order. So that's why when I see because left join usually checks the both here. And then second one she uses is right join. So with all stock items and their supplier. So this query is between purchasing supply and warehouse stock items. So the right join and makes sure all stock items show up even if they don't currently have a supplier link. So here the results. This is what results showing. So this I see it's useful because it ensures nothing in the warehouse hidden, and it can also point out missing or outed supplier information. So here, so the third queries I chose, which is order lines with more than 10 units. So here she uses inner join between order lines, and stock item. So that this condition of quantity greater than 10 filters for only the bigger prices. So here's the results. Okay, so these are the results. So this query is it's a good example of query that helps identify bulk buyers, wholesale activity or orders they may require special handling. So my four queries would be orders not yet invoiced. So here's she uses a left join, so between orders and invoices, and checks for invoice ID, which is null, and which will reveals the order and exit, but don't yet invoiced. So here's the execution here. So this database query actually is not showing no because all have them as is one invoice tag. And the last would be for the cross join, that five queries, customer with all delivery methods. The cross join actually pair every customer with every delivery method available in the system. That means it all show possible combination even they aren't actually used in practice. So here's the result. And here is the with same customer different delivery method. So it is useful for a scenario like planning or testing. For example, if the company wants to analyze what delivery method could apply for each customer. So that would be all for our presentation. And Asmin, you can take over.
All right, that ends the presentation for Shuli and Yusan. Next up is going to be Hayan and Zarin. You guys can go ahead.
Okay, so this is Hayan. So I will be presenting 5 queries from the ring. You guys able to see my screen?
Yep.
Okay. So for the query 2, this query using a left join, and count method and group by to show all customer categories. And because it uses left join, so even those with 0 customer, the counts will still target a customer ID to ignore all empty volume. So it ensures to accurate reporting of both active and inactive categories. Then we have query 3. So it combining left join with case logic. This query shows missing website link while counting orders per customer. So from here, we can see the missing website 0 and it's ordered by descending total orders. So it shows how to add business logic while maintaining data completeness. Then we have query 5. So here, a left join preserves a new customer without orders. While using max method to find their most recent order dates and group by to create customer level summaries, showing how to analyze optional relationships without data loss. So here you can see the dates is by descending order. Then query 7. This query demonstrates multi-table inner join chain, navigating from customer to geographic tables. The where cost filter for payment terms after joining, showing how to extract and filter relate data from complex tables. But here we have result as empty because it cannot find the matching result. And the last, we have a query using cross join, which generates a multiplication table, and the volume method create a temporary table to demonstrating how SQL can generate a combined dataset rather than just the normal query existing data. And here is the result. And I'm done.
Okay, my name is Zarin and I will be presenting Haiyang's queries. Can you guys see my screen?
Yep.
Okay. This is his query 4. This query is about checking for customers who do or don't have an order. It checks which customers have no orders and which customers do have orders. It uses a left join between customers and orders and then filters to separate the two groups. When I'm running it right now, I'm seeing a list of customers like Tailspin Toys across different locations, which confirms who exists in the system and whether they've placed any orders. And then his query 5 is about order counts and price. So it counts the total number of orders per customers and sums the total sales amount as quantity times unit price. It groups by customer ID and name. When I'm running it right now, I'm seeing customers such as Tailspin Toys in multiple cities with their total order counts and total revenue. Some with hundreds of orders and sales totals in the hundreds of thousands. This shows both activity and revenue contribution per customer. So his query 6 ranks salespeople by performance. It counts how many orders each salesperson handled and sums their total sales. It joins people to orders and order lines and filters to only people flagged as salespersons. When I'm running it right now, I'm seeing top names like Archer Lambo, with very high order counts, over 23,000 and multi-million total sales. This gives a clear leaderboard of top performers. And then his query 7 is about checking which item makes the most money. So this query looks at products. For each stock item, it totals the quantity sold and calculates revenue by multiplying quantity times unit price. It groups by item ID, name, and brand, and orders by revenue. When I'm running it right now, I'm seeing items like the air cushion machine and several types of bubble wrap near the top, with the air cushion machine generating the highest revenue. This highlights the most profitable products. And then his last query is about checking order status. This query shows each order status using a case expression. If the picking completed when column has a value, the order is marked completed. Otherwise, it shows pending. When I'm running it right now, I'm seeing order IDs with their order dates, expected delivery dates, and most of them marked as completed. This gives a quick snapshot of fulfillment progress. Okay, I'm done here.
All right, that ends Zareen and Hayan's presentation. With that being said, we have 7 people on our group, so I will go 2 times with 2 of my group mates. First, I'll go with Izaz, and I'll share my screen. Okay. Here, as you can see, I chose Izaz's top 5 queries that I think would be really cool to use. With that being said, also all of us utilized Python's Jupyter notebook submissions, so that should be fulfilling one of the criterias as well. With that being said, I'll start with this query. This one is us wants to top list 5 products that generates the most revenue. It's very simple stated. So he's connecting the stock item name with the total revenue using the join function. So with this, I can easily tell that the air cushion machine is, for example, the air cushion machine is making X amount of revenue, while the other product in 164 is listing another revenue. What what it does, it's basically showing each customer alongside the items they purchased. This would help me understand customer product relationships. It would be useful it will be useful to know affinity analysis, what would sell, what would not sell recommendations, and very simply, who buys what. That's one. Then the second one I wanted to go over is the top 5 salespeople by total number. Hold on, before I do that, let me get my notes in order. So yeah, so the second one I wanted to guess 5 salespeople by their invoices, right? So this query ranks salespeople based on the total number of invoices they handled. The purpose would be sales performance tracking, useful for recognizing high performing staff, distributing workload fairly, and planning sales incentives. Um, yeah, so it's pretty self-explanatory. So five sales reps, the invoices that they handled, and the total number of said invoices. So it's joining invoice with the person ID. That's that. One thing is us could have done is putting comments on each line. That way it would have been way more easier to go over said queries, maybe for a future project. But then the next one we could do is customers with the highest number of orders, meaning what invoices is accumulating the most amount of orders. So we can see, for example, Gojan is ID number 968, while this company's total orders have been 138 total of the database, while Bhavin Rai has 144 orders from multiple customers across. So this is basically, purpose would be customer engagement, so we can see which customer is buying from what vendor the most. Then useful to spot loyal customers for each vendor, and then targeting them to, rewards programs, like, how Macy and JCPenney used to, they still do, like credit card programs for the loyal customers. Same thing with Costco with their executive memberships. Then also maintaining strong business relationships. Number the second to last that I chose would be suppliers by the total value of products supplied. Uh, Value of products supplied, excuse me. Then this would be showing the top five suppliers based on the total value, the products that they delivered. So the purpose would be supplier evaluation, useful, it will be useful for negotiating better terms, managing key supply relationships, ensuring reliable supply chain. So basically what it's doing is, let's say this supplier, Fabricam, has supplied this X number of items to clients across the database, while Datum Corporation has only supplied 25,000. So this could be the least amount of products that this company has supplied, even though they could have a lot more items to sell, but they only sold 25,000 compared to their competition. This is using the join function again. Um, so purchase orders, so we would know as where. So yeah, so she's connecting purchase order with the supplier ID. So when we prompt the query, the supplier ID when combined with the supplied name would, give me the result. And the last one, five customers with the highest total purchase value, meaning which customer spent the most amount of money to for layman terms. So we can see at Tailspin Toys, online customers or whoever spent, this X amount of money, while at Nasrin, they spend this much. So, this will be useful for highlighting VIP customers, tailoring special offers, and understanding where most of the company's income comes from. With that being said, that's my end of the presentation. I'll stop my screen share right now. Also for Izaz, I'll share my screen one more time. Oh, if I find it. Where are you? Okay.
Okay. Hi, I'm Izaz, and I'll be going Asmine's top five propositions. So the first one, proposition one, select the first 15 customer names and their order info. The way this works is the query joins the sales.customer table with sales.orders table using customer ID, and then it selects the customer's name alongside order ID and order date, and the top 15 limits the output to the first 15 rows. And this is useful because this shows which customers are placing orders and provides a quick look at the orders connected to them. And it's useful for checking whether the database is correctly linking customers and orders. Proposition two, show those 15 orders and the salesperson who handled them. The way this works is the query joins sales.orders with application.people using the salesperson's ID, and it selects the order ID, the salesperson's full name, and the order date. And again, the top 15 limits the output to the first 15 results. And this is useful because this connects orders to the employee responsible, which is valuable for performance tracking, and it lets management see which salespeople are handling which customers and how many orders each salesperson is responsible for. Proposition 3, um, show customers who place fewer than 12 orders. How this code works is the query uses a left join between sales.customers and sales.orders, groups by customer name, and then counts how many orders each customer placed. And the having count filters the results so only customers fewer than 12 orders are shown. And this is useful because this highlights smaller or less active customers, and it's useful for customer relation management. And it also helps identify customers at risk of becoming inactive. Proposition 4, how this code works is the query joins sales.orders to sales.invoices and then joins application.delivery methods to bring in the actual delivery method name. And this is useful because this ties orders to how they were delivered, which is key for logistics and auditing, and it helps the businesses see what delivery methods are being used most frequently. Then finally, Proposition 5, show the first 40 suppliers and the products they supply. And this code works because the query selects supplier names from purchasing suppliers and stock item names from warehouse stock items. And it uses a right join to make sure all the suppliers show up even if they don't currently have any linked stocked items. And this is useful because this reveals which suppliers provide which stock items, and it's important for supply chain management, and the company can quickly check which products are linked to which suppliers. And yeah, that's the top 5.
All right. Chris, since I'm already sharing my page, you wanna go from here? Take over.
Okay. Yeah, sure. So can you go down or you want me to do I'll do
The top 5?
I'll do 5.
Okay.
Oh no, you can I'll do the rest then.
Oh,
This
you wanna share? Oh, the rest 5? Okay. Go ahead.
okay. So this query shows each customer and their primary contact details. It shows the customer name, their primary contact, their phone number, and their email address. The 20, I'm sorry, the 21st customers, the top 20 customers. So we're selecting the customer table is using that table, and then is selecting the customer name under that, and for the full name, phone number, and email address is using the application.peoples table as a left join, which means that if the customer is not there, it's gonna is basically if a phone number, right? If a phone number is not there, it's gonna give you no values. Wait, can you go? No, no. Okay, for this one it says it shows 10 orders with customers and salesperson details. So this one shows the order ID, the customer name, the salesperson, and the order date. As the same as before, is choosing the sales table, and is renaming the sales.order as O, and is selecting the order ID from this table. Then is using sales as the customer as an inner join to get the customer name, and also is using applications.people as an inner join to get a full name, and is also getting the sales.order for the order date. Go to the next one. Okay, so this one is showing is getting the top 15 customers by highest total orders. Here is using the sales.customer table, is renaming it as C, and from that table is getting the customers' names, and then is using left join to use the sales.orders table and is renaming as O and using their or their order ID and putting as a count in order to get the total number, the number of orders that they had. And then it's just grouping, it's just grouping. For this one, we're getting the rank of the salespeople based on the total quantity of items they sold. And yeah, so I can see here that my teammate got assistance for ChatGPT a little bit. So he's selecting the sales order lines and is renaming as OL. And then from that, he is using it to get the quantity and the quantity and summing all the total quantities to get the total number of items sold. Then he's using the as an inner join in order to select the sales.orders table. And let me see why you use this one for rank over.
We're
Okay,
short on time.
over sure and so. Okay, so then he's using the inner join to for applications.people as E, where he's getting the full name and stuff. And so the table key gets the salesperson, the total items the salesperson sold, and the rank they have. Okay, cool.
Okay then. With the time we have left, I'll quickly go over two of Chris's queries. Um, so I took, let's say, the first query, if I scroll properly. So the first query tells me it returns the customer name and the item they bought. So it connects the line to the order and the line to the information, and it tells me what item and what customer and what item they bought. Then if I look at my notes, ba-ba-bum. So, it maps each customer to every item appearing on their orders, includes customers with no orders via the left join chain. This would be useful for product affinity and personalized marketing. For example, we know who buys what, and cross-sell and catalog curation per customer segment. And with that, I would like to quickly end our presentation and do a quick overview of our GitHub. So if I share my screen one more time, you can see that we have created our GitHub. All our members have uploaded all their videos and IPYNB files, notebook files for their scripts. Then we are finishing up our README file to do an overlay of the project that we did. And also, as a redundancy, we will connect all our YouTube videos to the README file as well, so you have an easy click on option. With that being said, thank you for your time, and please do give us a fair grade. Let's stop share and stop recording.